Welcome back to PPV. I said in this video we will be looking at the basic three axioms in Armstrong's axioms so that we can have a clear understanding on how these things works. All right. So let's dive right in. Armstrong's axioms. First of all, we are going to start with reflexivity. Reflexivity. Reflexivity axiom states that if x or y, if y is a subset of x, if y is a subset of x, x functionally determines y is true. This can also be interpreted as, this can also be interpreted as, this can also be interpreted as x functionally determines x. How is this possible? Well, x is actually a subset of x layer. That's what we learned in set theory. That's what we learn in set theory. I think in the future there will be a playlist on set theory also. But as I was saying, x is a subset of x. All right. So we can say x functionally determines x. We can also say that this FD also can be derived. You may think this is useless. This is useless. Whether it is useless or not, this can be derived. And we know in the last video, we learned that we have to find out all the FDs possible in F plus. All the FDs possible in F plus. Therefore, whether it's useless or useful, you are going to derive this FD and you will be using reflexivity for this. And to explain this, I'm going to use an example. Let's say we have a relation with three attributes: student ID, student name, and student age. Well, they are giving the initial FD, a given FD is x is equals to stud ID, comma, stud name. They are giving this. Not I am writing this. They are giving this. And they are saying y is equals to stud age. They are telling you y is equals to stud age. And they are giving you x functionally determines y. Well, from this, I can actually say by using reflexivity theory, x is going to functionally determine x. Therefore, I can say stud ID, stud name functionally determines stud ID, stud name. Now I am going to break this into two. All right, I'm going to break this into two. Like A is equals to stud ID, and B is equals to stud name. Okay, now I can say x functionally determines A and x functionally determines B. I'm not talking about y. I'm not talking about y. That's a different story. I'm not talking about y. I'm just talking about the reflexivity applications. Okay. First thing was we applied x functionally determines x. Second one, x functionally determines A, where A is a subset of x. A is a subset of x. And B is also a subset of x. X is also a subset, but it's the equal set as x. So we can come up with three additional FD by using reflexivity axiom. I think you get an idea where we are going with this. So similarly, I will be introducing the second axiom, which is augmentation, and then the third axiom, which is transitivity. I will explain the definition again, and then I will explain it to you with an example so that we can come to a clear understanding how we can apply Armstrong's axioms. The second one is not that hard. That is augmentation. In augmentation, what you have to know is they are saying if x functionally determines y, then xz functionally determines yz, where xz means x union z. You don't have to mention this. I'm just telling you again. I have included this in the last video also. If you have doubts, please refer that and then come back here. Yz means y union z. All right. How can I put this in words? How can I put this in? Oh, here z is any set of attributes. Any set of attributes. Any set. It can even have x inside it. Doesn't matter. Doesn't matter. Don't care. Doesn't matter. Don't care. It can be used again. Right? So if uh, if an FD holds between two sets of attributes, if an FD holds between two sets of attributes, adding the same set of attributes, adding same set of attributes, which is z in this case, and two sets are x comma y in this case, same set of attributes z to the right hand side or to the right side. What is the right side here? Y. And left side, which is x here, right side and left side, results in a valid FD. Let's use the last example again, the relation that we used last time. The example was we had stud ID, we had stud name, we also had stud age. Let's say in this case the given FD is stud ID, x is equals to stud ID, and y is equals to stud age. That's what they are saying. Well, then x functionally determines y. Well, now I'm gonna introduce a new set, that is z is equals to stud name. Stud name. Well, as the augmentation axiom states, xz must functionally determine yz, and that's true. And that's true. xz will be stud id comma stud name. Stud id comma stud name. Even though it's a partial dependency, doesn't matter. We have to find that. We are going to find all the f plus, all the sets in, all the fds in f plus. Therefore, you have to do that. All right. So we have stud h and stud. This is one example in this specific relation. You can also add xx, but xx is x, so it doesn't matter. And you can also add xy if you wanted, but xy determines xy is like the first one, reflectivity. Because if xy can be considered as a, and then a will be determining a, this is like subset thing. All right, but that is not important here. The important part is augmentation. That's what I have done. All right, so we are done with second axiom. Pretty easy, இல்ல? ஐ மீன் ரொம்ப ஈஸின்னு சொல்ல முடியாது. பேசிக் தியரி எல்லாம் ஒழுங்கா கத்துக்கிட்டு இருக்காட்டி இது ஈஸின்னு சொல்ல முடியாது. But this looks pretty easy compared to the informal guidelines. All right, there was a lot of theory in that, but here the computations are easy. Everything is easy. Now we are going to transitivity. Transitivity. Transitivity is the third Armstrong's axiom. உங்களுக்கு தெரியும், this states x functionally determines y if x functionally determines y and y functionally determines z. Well, we can say x functionally determines z is true. Alright, so how can I put this into words? If there is an FT between two sets of attributes, if there is an FD between two sets of attributes. And if the first one or first set functionally determines second set, and that second set functionally determines third set, then first set functionally determines FD னு போட்டிருக்கேன், but you know the idea. First set functionally determines third set. எக்ஸாம்பிளுக்கு செய்யறதா இருந்தால், alright, I have to think of an example. That's the hard part. For transitivity, you can't use the old example. That's the thing. Well, let's say there is something like stud ID, and let's say there is marks, and let's say there is grade. We know if X is equals to stud ID and Y is equals to marks and Z is equals to grades. Let's say the given FD, the given FD is X functionally determines Y and Y functionally determines Z. You can say from this, X functionally determines Z. So stud ID functionally determines grade. This is transitivity. Pretty easy. And in the future videos, we are going to learn about some additional rules and finish Armstrong's axioms. But additional rules will take some time. But after that, we will be able to do questions by using formal guidelines, design guidelines for relational scheme.
Thank you for exploring Armstrong's axioms with us. If you enjoyed this video, give it a like and share it with others. Don't forget to subscribe and turn on the notification bell to keep up with the series. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.